Welcome to Educator.com. Today we're going to be talking about research designs, also known as research strategies. All right, but before we learn about experiments, it's going to be helpful to learn about other kinds of research strategies in addition to experiments, just so we could see why experiments are so special and different. But in order to understand those different kinds of research strategies, we're going to need to review variables and the relationships that they could have. So one thing you need to know about variables is that we've covered two broad kinds of variables so far. Categorical, categories as the variable levels instead of actual like numerical values, or continuous, where the values of the variables are numbers that are meaningful in some way. So an example of categorical variables are whether kids have pets or not, so the pet variable, versus continuous, which might be something like a score on a biology test. So then you could have maybe 1 through 100, and each of those numbers are meaningful. In terms of relationships, there's a bunch of different relationships we've actually covered, but all of those relationships so far have been descriptive relationships. So we've covered relationships such as linear relationships, curvilinear. We've also looked at relationships such as negative correlation and positive correlation. Right? But all of those relationships are descriptive. They're just describing what the relationship is like. They're not actually telling you whether one variable causes the other variable. Those are causal relationships. They're not necessarily telling you that one variable doesn't cause the other one either, right? So this is a new kind of relationship that we're going to be looking at. Now, only one kind of study, one kind of research design can actually look at causal relationships. And that's going to be through the experimental research strategy or design, right? This is the only one, and so that one's pretty special. So far, we've only covered these other kinds of relationships. All right, so before we go on to the nitty-gritty of an experiment, it helps to know what are the non-experiments, right? So not every type of research study is an experiment. Just because you collect data on lots of variables doesn't mean you have an experiment. We need to start using that in a more narrow context. A lot of people, I think especially in the media or press or popular press, they'll use it in a more loose way. They'll call anything an experiment. But usually we use that for a very, very specific kind of research strategy. So first, category 1 are the kinds of studies that are only descriptive. So these are descriptive studies. The variables can either be categorical or continuous, right? But they don't look at any relationships. No relationships. So they don't even describe relationships between variables. They only look at variables in isolation. So they're really only interested in the distribution of people's heights or people's IQs or the distribution of bacteria in the stomach, right? So they're only interested in describing one variable or a couple of different variables, but not looking at the relationships between them. So that's very important. That's the descriptive study. That's category 1. Category 2 moves on a bit. Here, we're interested only in continuous variables. So only continuous variables can be used in category 2, no categorical ones. And here, the only relationship we could look at is descriptive. So here, because we have multiple continuous variables, we often look at these on a scatter plot. Okay, so those are called correlational studies, and that's category 2. Category 3 has 3 different kinds of research strategies in there. One is experimental, the other is quasi-experimental, and the third kind is non-experimental. So in these, you need to have at least one categorical variable. You could have also continuous ones and other categorical variables, but you need to have at least one categorical variable. And here, you could look at both descriptive relationships, but for one of these, the experimental one, you could also look at causality. But you cannot look at causality with quasi-experimental, not quite, not all the way, nor non-experimental. So even though you can look at causality within category 3 research strategies, it's really only experimental research strategy that can look at causality. All right, so in category 3, let's break down these 3 different types. So experimental research strategy, you know that you need at least one categorical. And that's actually the case for all of these. At least one categorical, at least one categorical. So that's what these 3 have in common. But for experimental, you could look at both descriptive relationships and causal relationships. You could look at both of those kinds of things. For quasi-experimental, we could look at descriptive, and we could actually sort of come up with causal explanations, but not quite. And that's why it's called quasi-experimental. Sort of look at causality. It gets close. It gets pretty close as you can be without actually being experimental. And for non-experimental, you can only look at descriptive. So these are the 3 different kinds. Quasi-experimental ones are also often called accidental experiments. Or one very common example is using pre-test and post-test, where you're looking at how something in the middle is causing it, but you also have sort of this confound where because you're testing people 2 times or you're measuring something twice, it might just be an artifact of measuring something twice, right? For example, if you wanted to know how good a math software is, you might have a pre-test and post-test, but people might just get better just because they did the same test twice, right? So that's why quasi-experimental, sometimes it has some issues. Non-experimental variables are going to be quite different from experimental categorical variables, and we're going to talk next about what the difference is. Okay, actually, before we do that, we're going to first talk about why can't the other strategies determine causation? Because it seems so exclusive for experimental research strategy. What's wrong with the other ones? Well, all of the other strategies have 2 fundamental problems that they cannot escape. So here's the big issue. We have some variable 1, and we want to know whether variable 1 causes changes in variable 2. For instance, let's say we want to know if having a radio in a developing country will lead to women having fewer children. So if your household has a radio, does it mean you have fewer children in your house, or greater use of birth control, right? So that might be variable 1, radio, right? And variable 2 might be something like use of birth control, right? And we want to know whether one variable causes the other variable. Because if we knew about causation and we wanted to reduce or we wanted to increase the use of birth control somewhere, then we could adjust radios in households. We could give people free radios or something. And then, and by doing that, change the use of birth control. But it would be nice to know whether this causal relationship actually exists or not. Now, one thing you could do is, ask people whether they have radios, and then ask people how much they use birth control, right? Whenever you do studies like that, and that would largely be a non-experimental design, because this is a categorical variable, radio, no radio, and maybe use of birth control might be how many times do you use birth control in a month, right? And maybe that's continuous. Here, one issue is you don't know whether one causes the other because we have what's called a third variable problem. And the third variable problem can be described like this. There might be another variable that actually impacts both your variable 1 and 2. So this is what we call an extraneous variable, one that's sort of outside your scope of study. You're not looking at it in your study. So this extraneous variable might actually impact both variable 1 and variable 2. And so you might see variable 1 and variable 2 having a relationship together, like when one goes up, the other goes up, when one goes down, the other goes down. You might see that relationship, but that relationship might actually be caused by a third variable that's affecting both of those. So for instance, perhaps how much money your household earns affects whether you have a radio, but also affects use of birth control. Or the level of education that a woman has might affect whether they own a radio and whether she uses birth control. So those things might be caused by something else. So they look like they're moving together, but they're actually not causing each other. One sort of picture that I like to draw for my students, sort of mental picture, is this idea of, let's say there's two boats. There's a little blue boat, right? And there's a little red boat. Okay? And, whenever you see the blue boat sort of rise up in sea level, the red boat rises up in sea level. And when the blue boat goes down in sea level, the red boat goes down in sea level. But actually, both of those are caused by the water, right? It's not that the blue boat is actually causing the red boat to go up or down. It's really the water that's causing both the blue boat and red boat to go up and down, right? So in this case, this might be variable 1, variable 2, and the water is the extraneous variable, right? And it might really be this extraneous variable that you're not studying for some reason, that's really causing the both of these things, right? So that's always the problem in these other in non-experimental correlational designs. They always have this problem of the third variable that might be lurking back there. The third variable is often also called a confound. So something that's moving along with variable 2, the variable of interest, but it's sort of sneaking in there. We're not measuring it, so we don't know about it. Okay. And even so, even when you solve this third variable problem, sometimes you still have another problem that remains. And this is called the directionality problem. We don't actually know whether variable 1 impacts variable 2, or is it that variable 2 impacts variable 1? We don't know how to distinguish between those. And so that's called the problem of directionality. Even if two variables have a relationship to each other, either a positive correlation or negative correlation, we don't know whether X causes Y or Y causes X, right? And that's hard to distinguish in a correlational design or a non-experimental design. So let's say we take a correlational picture. For instance, here, let's say that variable 1 is women's education, a woman's educational attainment, right? And variable 2, let's say, is use of birth control. Well, we don't know whether a woman's education actually impacts the use of birth control, or perhaps it's that using birth control allows women to stay in school longer, right? So it could be either one of those directions, and we don't know from doing a correlational study. Let's say we ask women, how many years of schooling have you had? And we ask women, how often in a month do you use birth control? That would be a correlational design. But one issue that we'll have is we don't know whether X causes Y or Y causes X. And on top of that, right now, we also don't know whether there's a third variable lurking that might be more explanatory. All right, so experiments have found a way to solve both of these problems. They solve the third variable problem and the directionality problem. And that's why experiments are special. So here's how experiments have solved the problem. They're special because they use manipulation and what we call control, right? And manipulation and control, these two solve the third variable and directionality problem. Here's what we mean by manipulation. Manipulation means that in an experiment, the categorical variable, the variation is created by experimenter or researcher team, right? So it's not that we just ask women, hey, do you own a radio? It's that the experimenters actually go in there and create that variation. They might take a whole bunch of people, none of whom have radios, right? So they're all the same at first. But then the experimenters create variation by randomly assigning half of them to get a free radio, right? So in that way, the experimenters are the one who is creating. They're the ones mucking around in there, right? And that's manipulation. So the categorical variable gets manipulated. And whenever you think manipulation, I want you to think, like created, like rolling up your sleeves and getting in there, making them a certain way. And that's one thing that experiments do differently. Now, how does this address the third variable problem? Well, it addresses the third variable problem because the experimenters created some condition, right? They created the radio condition. It didn't exist before, right? So even though, and then once the experimenters introduce this, then they look, then you could look for changes in the second variable. Now, the experimenters didn't do anything to that second variable, but if that second variable changes after the man-made change, then you know that it's caused by that man-made change, because all other things stayed the same, right? Their level of education and their socioeconomic status, everything else remained the same. The only thing that changed was the introduction of that radio, right? So they address the third variable problem. Check, right? What about directionality? Well, the way that they solve directionality is like this. They gave them the radio. The experimenters gave the participants the radio. Is the radio caused by birth control? No, right? Because the experimenters caused it, right? We already know how variable 1 was caused. It was caused artificially by the experimenters, right? So because we've ruled out that y causes x, or variable 2 causes variable 1, now we know there's only one direction that could possibly be the case because we've ruled out the other one. So this one, we rule out variable 1 causes variable 2, right? We've basically ruled this arrow out because we know what caused variable 1, the experimenters. All right. So that's one of the important components of an experiment, that they have manipulation of your categorical variable. The second component is what we call control. Now, often people mistake the word control to mean, manipulation, but I need you to separate that in your mind. When you think of the word control, I want you to think isolation. Isolation. What you need to do in order to have control is isolate the variable of interest. So everything else has to be the same except for this one thing that's different. For instance, having our radio, right? So the problem with other studies is that they don't have control. The people who have, the women who have a lot of education, they might also be wealthy, right? Or live in a different neighborhood, or already be using birth control, right? So those women are different in many, many, many ways, many, many variables. What we want to do in control is isolate variable of interest. And how do we do that? We make sure we have two equivalent groups. First, only difference is manipulated variable, right? So what we want to do is start off with two groups of people that look exactly the same for all intents and purposes. So we have two groups, right? They're all the same. They're women, they're the same mix of, there's some rich women here, there's some poor women here, there's some educated women here, there's some uneducated women there, right? But also, this other group has the same mix of women, right? Once you have two equivalent groups, then one group gets something different, right? And that is the manipulated condition or the treatment condition. And so then one gets the manipulated condition. And the other that doesn't get anything special is called the control group. And it's because we want to compare these two groups. Because they only have one thing that's different, right? There's only one variable that's different. Then we know that any other changes that come from that point on is caused by that one difference. Because for everything else, they're the same, right? And that's what we call control. Remember, you have to separate in your mind the word control. We don't mean this when we mean control. That's manipulation. When we mean control, think of this picture. Separating out, right? Isolating the variable of interest, making two equivalent groups, having only one thing be different, right? Okay, because when you have two equivalent groups and only one thing is different, that one stands out, right? That's how we isolate the variable. Okay, so how does this solve the third variable problem? Well, here's the thing. By having two equivalent groups, you've ruled out the other variables, right? So having the two groups, two equivalent groups, that rules out the third variable. Because on all these other variables, like how rich, how poor, ethnicity, whatever, on all these other things, these women are roughly equivalent. How do we solve directionality? Actually, control by itself doesn't actually address directionality. It has to be control plus manipulation in order to get directionality. So really, directionality is taken care of by manipulation. So I'm going to cross that out. All right. So these two things are what make experiments special: the manipulation of a categorical variable and the control, or what we call isolation of that variable, having a control group that's identical in every other way except for that one manipulated difference.